Can you see if you get any sound? At least I'm hearing something. Is it still live?
Yeah, there's a little bit of okay. There's a little bit of delay, but it's okay.
Yeah, it's still live. Right. Should be good enough for them to hear what I'm saying and see what's going on in here. It also records the audio of the presentation, so this is good. Hey, morning. We still have 4 minutes or so. Still have time for coffee. I think it's better you turn it off, otherwise it's going to create like a feedback loop. That's pretty cool. So we finally got the video recordings to work. So we have also students remotely in La Paranta and Rovaniemi. So some students who are attending to the class, but they are there. That's why we have had this struggle setting up this Google Hangouts and all these things, because it's the first time we're doing it. So it's yeah, it's been interesting. So there was this confusion about the class code. So in WebUD, it has the new name, because it used to be mobile and social computing, and we split up the class into two. And the old code was that one on the left, but the new code for the registration is on the right. And so some people were looking for the old code, or maybe I think it's WebUD has the new code, but it has still the old name, or something like that. And then if you look for this code or this name in Optima, which is what they used to use, you can't find it. But I sent an email to all the registered students through WebUD to point them to the classroom, so it should be okay now. Just in case you have a friend who has not yet know that we are using Classroom and is still wondering what's going on, please tell them to email me and I will give them the code to join, or just tell them what's the code, and they can join. So. I think we should get started. We have quite a lot. So it's 8:16, so we should get going. Good morning, everyone. So today we're going to talk about sensing the world. And what I mean by sensing the world is not just sensors, but everything that comes with it. So we are right now on week 3 of the class. We have 1, 2, 3, 4 more early morning classes, okay? And then the project work, we don't meet anymore. So basically, we can meet if you have questions regarding the project or if you have difficulties regarding the project. But you'll probably most likely meet the TAs during this time. And then we'll have some deadlines in there, but we will keep you up to date using Classroom, so that also helps. All right, so let's continue here. So what is a sensor? Any ideas? What do you think is a sensor?
It's an equipment that gives data.
A device that gives us data. That's correct. Anything else? So right now I have about 3 devices on me, or sensors. Which one?
An equipment, it's how it works.
It might not be equipment, but if you think about it, you yourself are a sensor. You keep scanning the environment, right? So a sensor is anything that can measure, okay? That's a sensor. So that means including you as a person. You experience the cold, I mean, you live in Finland. And doctors, for example, they often rely on self-reported data to make an assessment, whether you're sick, how you feel. That's basically using yourself as a sensor. Of course, there might be biases and there's error, like a normal sensor does, like a device. The human also does the same. So yeah, so a sensor is anything basically that can collect data. We are mostly used to the sensor that you have on your device, on the device. If you think about a smartphone nowadays, there's a lot of sensors in there. So for example, what we've noticed is that in the old days, you had pretty much one sensor, maybe 2 sensors. One of them would be for your network connection, that connects to the cell tower. It provides you the signal for you to be able to talk with other people. The other one is the microphone, for you, so that the other person can hear you. But now you have cameras, you have accelerometer, you have GPS, you have magnetometer, gyroscope, fingerprint reader, proximity sensor. But a lot of these sensors, they're normally used for improving the interaction you have with the device itself. So if you think about it, the proximity sensor is used to check whether or not you have your phone in your pocket, so that it avoids turning on the screen even if you press the power button, for example. Or make sure that the screen turns off whenever you take a call. You put your phone next to your ear, the screen turns off, otherwise your ear is going to be interacting with the screen doing all sorts of funny stuff. Okay? The humidity sensor, for example, can be used to detect whether or not there's been a water spill into your phone. It can be used for warranty purposes, for example. Ambient light, for example, allows the device to adjust the brightness of the screen depending on how dark the room is. So if you use your phone in the highest brightness and the room is dark, your eyes are going to hurt. So it adjusts automatically to that. Yeah, so that's just some examples. And like I said, normally it's meant for device functionality. So for example, auto-rotating the screen. So if you flip your phone landscape, you expect the interface to change to adapt to that change. Noise canceling. So the fact that you can hear very clearly someone is because they are processing the audio that comes into the microphone to remove the noise that you hear. And then, of course, the turning off the screen when on a call. There are other things like, for example, doing human behavior and context modeling. That's what I do as a job. I'm a researcher. I use sensors for mobile devices. And normally I use that to build smart applications, things that react to the user's data. So for example, things like Fitbit or fitness trackers, diets, sports trackers, all of those use the accelerometer, they use the GPS to give you data that's meaningful for you, that understands you, and basically that's a good use of the sensors on the device. And the other thing is, you know, what the phone is for. Calling someone, texting, maps, playing games, Facebook, all these things, okay? So the amount of sensors that comes built in on your devices is actually growing a lot. So if you think about history, 2010, the Samsung Galaxy S1 was one of the first devices that actually had the ambient light accelerometer, magnetometer built in. The S2, they added gyroscope and proximity, then they added air pressure. This is a light sensor. Then they have humidity, that's a magnetometer in there. What else? Temperature, and then now heart rate and fingerprint. And more devices are having these things. There's actually a prototype of a device that can actually measure the glucose levels. So you don't have to pierce your finger to measure your, if you have diabetes, to measure your sugar. Why are they doing this? Well, the reality is that they are finding very good use cases to having a device on your pocket that can monitor your health. And that's something that, if you think about it, it will reduce significantly the costs of having you to go to a doctor to do physical exams. Especially if you're thinking about like poorer countries, if they have access to a device that can do a lot of things that would normally require specialized equipment, that you can just put your finger on a phone that has a sensor that monitors certain things, it saves a lot of people's lives. And basically that's a huge market for device manufacturers. For us, you know, it just means that your device does a lot more. But it also means there are the challenges with that, which means the more sensors in there, the more likely you will use the device, which means the battery life is going to decrease unless they do something about that. Okay. So I have a small video actually that Google made explaining all the sensor components in the device and how all of these come into play. I found this video very interesting, so I will just put that playing for you guys so you can see how it actually looks like inside. Oops.
Where neighborhoods are sealed under layers of copper and glass. You're about to enter.
Hey there, welcome back. I'm Nat.
And I'm Lo.
And this is our 20% project, where we go find out about different Google stuff that we're curious about.
And in this episode, we're taking apart a phone to learn what's inside of it and how that stuff actually works with our friend Dan.
Dan works on the Android team, and his real job is helping developers make gaming apps. But in his spare time, he likes taking apart hardware. You're a pro at teaching, and then...
I'm an amateur at breaking things.
Okay.
and taking things apart.
All right, let's start taking apart this Nexus 5.
And so when you open up kind of anything, will it look basically the same inside?
It'll have similar components, and those components be organized in similar ways. So you've got a display, cameras, microphones.
There's a case,
The battery,
a SIM card slot, speakers, and a sensor that can tell whether or not a phone is near your face.
This is the gyro and the accelerometer.
They're both sensors that are useful for playing video games and fitness apps because they can tell your phone's movement.
There's the motherboard, which is the main printed circuit board and does a lot of different stuff.
A lot of phones also have daughter boards, which are an extension of the motherboard and can be all different shapes and sizes.
Then there's also the fatherboard.
Is there a fatherboard?
No, I just made that one up. Testing you.
Almost every useful component you would see on the phone is actually on this board.
It looks like there's little neighborhoods on the board, like this is separated.
There are.
It's like
suburbia.
So,
Absolutely.
yeah, it's like looking out from a plane window and seeing, you know, like these little separate areas. So are they actually separate?
They are actual neighborhoods. That's a great way of describing it, actually. You can see both sides of the board have different neighborhoods.
For something like Project Aura that has all the different
Right.
components that you just slot into your phone. It's
Right.
not like making one of those little neighborhoods just independent.
Absolutely. That's exactly what, when you look at this, you can already see kind of like what Project Aura is trying to do. So one thing we aren't able to take apart is this front display, and that's because this is all glued together.
But Dan explained that if we were able to take it apart, there'd be all these different layers. Glass, insulating material, protective coating.
And sandwiched between those layers are two very important layers. They have these super thin copper wires, actually thinner than a human hair.
There's a layer of wires that are horizontal and carry an electric current, and they're called the driving lines layer.
And then there's the layer of lines that are vertical, that are called the sensing line layers.
And together, they form a grid. And this grid has an electric charge. So basically, when your fingers get close to the screen, because they're good conductors of electricity, they disrupt the grid's electric charge. And the processor picks up on that, and it plots it on an XY axis.
So it can figure out exactly where you're touching it and can then route that information wherever it needs to go.
A phone is a really sophisticated computer combined with an enormous number of radios.
Not like the radio that you listen to in your car, but like a two-way radio.
So a quick question. Why doesn't the screen then work when we have gloves?
Because it is insulator.
Sorry?
Insulator.
Exactly. So it also, even in the cold, I don't know if your phones work very well when it's this cold. It also affects the resistance. So what happens a lot is that some devices, for example, because it's so cold, your finger is not as warm, and then it doesn't process very well the signal. And then basically you get funky touches and things don't work exactly as you expect it to be.
Yeah, like walkie-talkies. So your phone can transmit data or it can receive it. So your phone has a cell phone radio, and that communicates with a cell tower whenever you're making a call. Then it's got a Wi-Fi radio,
And that's good for downloading big files or streaming video. It actually uses less battery because it has less distance to go.
it has a Bluetooth radio for connecting to maybe speakers in your living room.
And if you've ever tapped your phone to pay, that's going to be using your NFC radio. It stands for Near Field Communication.
Because it can only travel like 1.5 inches in range.
And last but not least, there's GPS, which of course is really useful for real-time mapping and in case of losing phone.
And all those radios actually make it pretty tricky and interesting to design phones because you can't have them interfering with each other, and they're all packed in there super close together. Dan, what are you doing?
I'm putting it back together, of course. Well,
How's it going?
see if I can. It's going pretty well. So,
Yeah, just your average try. What's your prediction for phones in the future?
this year we're seeing a lot of cool stuff in terms of what we're doing with Project Cardboard and people using these phones as a basis for a virtual reality player. So you want to go and be somewhere else, you want to see it in Street View, you want to see it in 3D. You can use this with a couple of lenses and a piece of cardboard to be there. And I think that's just scratching the surface of what we're going to see in terms of phone technology and how it can provide you that sensory experience.
So what did you learn about phones from all of this?
It's a lot more fun when you actually know what's inside the things you use every day.
Yeah, it was interesting to learn how all these different things are laid out together. So there's probably as much, if not even more, design on the inside of the phone than there is on the outside. We wanted to thank you for taking the time to do this today. So you'll hang tight and I'll go get something.
since Dan broke apart his phone for us, as a thank you, we decided to give him something else to break apart.
All right. So that's a phone. Now you can understand the complexity that goes into building one of those. And also why is it so expensive when you break it? Because a lot of the times you don't break just one component, you actually end up breaking a lot of them. They are getting cheaper to produce, to manufacture, but still they are quite pricey. But the prices have been going down. So if you think about a smartphone, in the old days, they would cost like 200 euros or 300 euros. What you got for the money you paid was much less than what you get nowadays if you pay the same amount. So I'll go now a bit more deeper into Android itself in the sensing part, and then Yuki is going to talk about iOS. So I already mentioned quite a few of these. So we normally categorize sensing based on what they can do. So these are motion sensors. So these motion sensors either detect the device motion or the motion of the device in relationship to Earth. So we have the accelerometer, which basically measures how fast the device is moving, including the effects of gravity. So if you leave your phone on top of a table without touching it, there's actually a measurement that it's measuring on the z-axis. So if you think about the axis is like this, so that's the z-axis. Okay, so if you have this like this means that the z is pointing up. So there's a force happening right now on the device, pointing down to the center of the Earth, which is gravity. And that value is going to be 9.78 something, okay? And that's always there. And so the accelerometer measures that. So it measures the force of gravity around the device. Then gravity just measures the gravity sensor. So it removes the acceleration, just keeps the gravity. The linear accelerometer that keeps the accelerometer removes the gravity. So there's processing done already for you, where you get the actual speed of the device, ignoring the effects of gravity. So if you're doing things like a step counter and things like that, that would be the best sensor. So you get the highest quality data, okay? Then you have the gyroscope, which basically measures the rotation speed of the device, okay? And that's in radians per second. And then you have the rotation angle, okay? So if you combine these two, you can actually get a good feeling of how is the device on someone's hand, for example. Or is it on your pocket? So you can use these measurements to know, okay, the phone is upside down, it's moving in a specific rhythm, for example. You can tell whether or not the device is actually in someone's pocket. The position sensors. So for example, the orientation one actually has been deprecated, but it used to be there where it actually gives you what pilot are used to. So for example, they are used to use measurements like pitch, roll, and yaw. And basically what it does is it gives you a sense of the angle that the device is in relationship to the floor. So if you think about like a joystick of a plane to pull it up, so it gives you the angle of the motion as if the device was standing on the floor. This was actually removed because it used too many sensors to calculate this. And so they just removed that. Then we have the magnetometer, which basically measures magnetic fields around you. So if you use this sensor, you can actually detect metal. So if you put your phone next to a keychain or something like that, it will actually, you can get that. You will see the value go up. And then there's a proximity sensor there, which basically measures the distance between the surface of the screen and any obstruction. So this can also be used when you're taking a phone call. Depending on the device, you can get okay. Let's see. Depending on the device, you either get close, not close, or actually measurement in centimeters. And this depends on the phone. Okay? So when you're programming, you'll need to either adjust your code to either consider centimeters or the fact that there's something there or there's nothing there. Okay? It's a 1 or 0 that it returns. So if there's a 1, that means that something's obscuring the screen. If not, then there's nothing there. Environment sensors. Okay. I think I will have to keep pushing this. So we have ambient temperature, light, air pressure, relative humidity, although this is very rare. Only the Samsung S6 has this sensor, as far as I can tell for now. They removed it, I don't know why. And then we have the device temperature, which actually has been deprecated. You cannot get the sensor anymore, but you can get it from the battery manager. So if you want to know like how hot your phone is going, you can get that value from the battery manager class in Android. So for example, you could make an alarm whether your phone is going overheated, for example. There are some researchers that use this sensor to know how cold it is outside. So by monitoring the temperature of the device itself, if you have your phone, let's say, in your pocket, the temperatures drop. So you can use that to have an idea of, are you outdoors, for example, versus indoors. Okay. So in Android, it actually is quite easy to get the sensor data. There's one class called Sensor Manager. And this Sensor Manager basically allows you to query what are the device sensors that are available on this phone, for example. And basically, with that, you can specify what we call a sensor listener. And this is a callback that the operating system gives you, where it tells you, okay, this is the sensor that exists, and this is the last reading that it has sensed. You can specify how often you want to get this callback call. The more frequent you make that callback, so the faster you ask the sensor manager what is your last measurement, the more battery you're going to drain. Okay? Because if you think about it, the sensor works every time the operating system gives power to it, collects a measurement, and gives it back the value. So this sensor event has the name of the sensor. So you can actually use one listener for collecting the data from all the sensors, for example. The timestamp, so when was the event occurred. So this is actually quite interesting because in general, people think, oh, the sensor just detected this, but actually that measurement might not be the current one. So if you think about some sensors, for example, the battery value does not change in real time. It takes time to change the value. So a lot of the times when you get the sensor, the event of the sensor, for example, the temperature, it's actually not right now, but it might have been 5 minutes ago. Okay, so keep that in mind. Then there's the accuracy. So the operating system gives you an estimate of how accurate it thinks the value was. This is quite important, for example, for the location. So if the accuracy, if you look at location traces, the accuracy is going to be really bad if you're indoors. And that's reasonable. I mean, you don't have GPSs on top of you, so they cannot pinpoint exactly where you are. So the accuracy is going to be anything between 200 meters to a kilometer, which can be really far away from where actually you are. And then the sensor data. Okay, so there are two callbacks basically in this listener. One of them is the accuracy change, so you can actually monitor whether the signal got better, and it gives you four states. 1, 2, 3, 4. Yeah, 4 states there, or 5 states. And basically, they just give you a measure of how reliable the device thinks the data is. So low, medium, high, and unreliable. So 4 states. Okay? So this allows you to basically either wait for more accurate data, or just tell the user basically, you know, I'm showing you something that might not be reliable, basically. And then every time the value changes, this callback is called on sensor change. It has a sensor event object, and then in there it has all the measurements I mentioned before. So the kind of sensor, the accuracy, and the data itself. And so when you create an instance of the sensor manager, you can create these sensor event listeners, and then basically you get these callbacks for the sensors you want. In the labs, you're gonna learn how to code these, okay? So I already mentioned these, so GPS, Wi-Fi, Bluetooth, network. The touch screen is a sensor if you think about it, the microphone again. So for example, researchers have been using it to detect like ambient noise. Are you in a noisy environment or not? So if you think about the context that I mentioned before in the previous class, how do you get the people's attention? So you can use the microphone to know whether or not it's a good time to show you a notification, for example, or to beep and things like this. The camera can be used to detect objects, face recognition, things like this. Even the calendar can be considered a sensor. Whether or not are you busy, do you have something scheduled, okay? This is what we call software-based sensors. And I did mention in the beginning of the class, for those who are late, so we were talking about what is a sensor. And the discussion here was?
Sensor is everything that can be spatial.
Yes. So a sensor is anything that gives you data. And that includes us as a person. So if you think about, I give the example of self-reported data for doctors. So a doctor talks to you and asks you, how have you been, how have you been feeling? So basically you're acting as a sensor right now to give to the doctors a measurement that they cannot do with hardware, right? So they tell you, okay, I've been feeling sick and things like this. Of course they can measure like, you have a fever and things like that, but you will exhibit symptoms that are very difficult to measure just using hardware data, okay? So Yuki's going to talk now about the iOS side of things. So you can, yeah.
So I'd like to talk about iOS stuff. So iOS also provide almost same sensors on Android. So accelerometer and gyroscope and magnetometer, and also device motion is, it means it's measure the orientation of a device. This is calculated by iOS API. And also the, in addition to the motion sensor, we have a high-level API. We can automatically detect step count and activity recognition and shake motion and orientation. So you can make your original application very easily using this kind of API. Also, iOS have location sensors. It's mean the GPS. So, yeah, this is, so I got this picture from Wikipedia. So actually in the on the Earth, there are lots of satellite is running on the Earth, and so this is the actual location, and the phone receives the signal from the satellite and measure the location. So and also in the location API, core location, it means the location library. We have our air pressure sensors and compass and Bluetooth. So maybe this is not our Android. So IDFON is a iOS provide. Apple made one, I can say, protocol for measuring the distance between the beacon. So you can use it on the iOS. So this is other sensors on iOS. I think the iOS sensor is not so a lot than Android, but you can use Wi-Fi and touch screen and virtual level. You can use almost same sensor on Android if you want. So this is okay for reacting the sensor data. This is one example for accessing to the accelerometer sensor. So it's very simple. You just check the motion sensor is available, and just set the interval. This case is 60 Hz, and just set the timer and start the sensor. You can access this data just this kind of code. Also, the location sensor is almost same code. You can just check the location sensor is available and just start sensor with the timer. Yeah.
Okay. So basically, the iOS side, there are some sensors that you have access, but it's also quite restricted in what you can actually do with the sensors themselves. It's getting better. So Apple has been opening up a lot of these sensor APIs over the years. So you can do much more things than before you couldn't. So how do you interpret sensor data? And so this is the million-dollar question. So basically, a lot of companies nowadays, they are just trying to find ingenious ways of using the data, okay? So in a nutshell, it's 3 steps. So one of them is to read data, make an inference, and then take an action. The problem is there. Make the inference is always the challenge. And so basically, that means understanding what the data tells you, okay? Data is noisy. You need to be able to analyze it and understand what is it telling you. So there are typically 2 ways of understanding the data. One of them is dynamically inferred, which means that the code adapts to the sensor data. And the other one is you design it according to your rules. So this one, the rules change over time. This one doesn't, okay? You know, your project, for example, you could think about how you can use these sensors to do something that you haven't thought of right now, up until now. I will give you some examples of that later today here, but here's an example for motivation. So basically here they're using the camera, they're using the gyroscope, they're using the accelerometer to show what they're seeing here is actually presented on their device. And they play a soccer game where they have to push the ball forward and backwards. You can actually test the game if you want. Here's another example. Has anyone seen this before? This is called Ocarina. This was one of the top 10 apps, like maybe 5 years ago, something like that, on the Apple Store and also on Android. For those geeks in here, you know what this song is, so. If you've never played Zelda, go play it. The source code for this is actually there, if you want the link.
Oh, right, that's exactly.
Right there, okay? So basically, this just uses the microphone, detects the audio, the sound that it does, and then depending on how hard you blow, it makes the sound go higher or lower. Pretty simple, but basically it's predetermined behavior that was coded into there by design, okay? And so other examples. Here's another example. Basically, there's the code in there. So this code actually allows you to, when you're running, you can just do this to change to the next track. So you don't need to remove your phone out of your pocket. You can just keep running and you're listening to music, and then you jump and it skips to the next track if you want to. So that's another use of sensors. I don't know if it's the most useful. You might hurt yourself, but you know it does that. So Android does something very well that actually Apple started doing that too, which is supporting what we call open intents. And open intents are basically broadcasts that you can send to the operating system. Depending on the app you have installed, it will react to that. So Spotify has support for this. So you can actually integrate with Spotify, where you can send a broadcast to say next music, increase the volume, lower the volume, stuff like that, from your app. Okay. And this is actually the callback, the broadcast that, for example, the native music player from Android supports. So, for example, if you want to ask the player to stop, to pause, you just send that intent, send this broadcast with that command. Command pause, that's it. And that's the action that you put there. So basically what this action is what is the class it's going to call, and what is the method it's going to, you want it to do, that's it. But like I said, Spotify also has this. If you search online for open intents, Android open intents, and you will find a huge list of different apps, different things. Things like, for example, Google Maps, where you can show, okay, where am I right now? And you will open Google Maps with a position. You can use it, for example, to take a picture. You never thought about that, but for example, you don't need to code from scratch a camera app. You can just say, open the whatever camera app you have on your phone, take a picture, and give that picture back to me. I want to use that on my app. You can do that, okay? All right. It can also be used to detect, for example, what's around you. It's beyond your phone. So you can think about, for example, social. So things like, are you in the same network? What other devices do you have around you? Do you have a printer? Can you print there? Is someone around you? So for example, things like Bonjour and Samba allows you to know, for example, if someone's connected to the same Wi-Fi network, and you could chat with that person without having, to install a specific app, for example. Google has Google Nearby API, which kind of obfuscates all of those to know if someone is around you. So I can use this Google Nearby, for example, whenever I'm using, for example, my TV. Android TV has that support. I'm on the same room, and if you try to cast, it will tell you, okay, you have a screen that you can use to put your content. Or if you have, for example, Google Home, you can use it as a speaker. And you can say, okay, I want to put the music that I'm listening to playing these speakers. So basically, that's Google Nearby Play. That's open to everyone, so you can definitely use that for your app, for example. You can also do location tracking. So you can do location tracking by network, and that's usually cheap in the sense that you get a relatively good accuracy without having to rely on the GPS, so you can use that indoors, which is kind of what Yuki was telling about the beacons. So Apple really wanted to monetize indoor positioning for advertisement, whatever, and also their own Google Maps, Apple Maps, sorry. So basically to allow you to know where you are inside the building. So you can do that, and then this is usually used as a first step whenever you ask a location on your phone. It starts by trying to figure out where are you really fast based on the Wi-Fi and the network signal towers. And then while it's waiting for getting the satellites to pinpoint exactly where you are, because you have the distance between your phone and the Wi-Fi access point is much less between your phone and a satellite in space, right? And that consumes a lot of power to measure that. So basically, they just do that. They just keep track of, okay, where are you at any given time by using the network provider and the Wi-Fi. And then whenever you're outdoors and you really want high accuracy sensor data, location data, then they switch to the GPS, okay? It's just because it will give you the illusion that it's really fast. But if you open, for example, Google Maps, the first 5 seconds or 10 seconds, what you'll see is that there's this huge error margin that they give you. Okay, your location is somewhere here, and then it tries to narrow down to where you are, okay? So using Bluetooth, was quite popular, and it still is, to actually know if you're in the same room. If you think about a device, a phone as a personal identifier, basically you can know where someone is just by tracking your Bluetooth. How many of you keep the Bluetooth on? You have your Bluetooth on? Okay. I'm not so sure. I do keep it on because I have wearables, and so basically it's a trap. You keep it on so that these can talk with the phone, and then the phone can be used to track you. To fight that, actually, Apple and Google have now randomized your MAC address. So MAC addresses are this unique ID for your hardware on your device. And basically what they started doing is every time you turn on your Bluetooth, you get a randomly new MAC address. And that kind of destroys this kind of tracking that they used to do to know whether or not you're returning to the same store, for example, and things like this. When I was a student, that's my supervisor over there. I installed the software on his phone, and I was just trying to figure out who does he mingle with. I did this with his permission. And basically, you want to know like who are the people he meets the most every day. And basically, what you have here is, so Nick was his student, and Eamon is my supervisor. And basically, the closer it is to him, that means the more often you meet this person. We can't do this anymore. Like I said, the MAC address keeps rotating. That means I cannot know if it's the same person, because the MAC will be different. It will always be seen as a different person that's around you. So that doesn't work anymore. But anyway, this is the kind of social engineering that you can actually do using this sensor data. So let's think about this a bit. Mobile phone, always with you all the time. And you know, you can use the sensors in very ingenious ways to tell more about what the user is doing and also augment what they can do, right? So you can do programmatically, you can code what the sensor is going to do, or you can actually design the app so that it leverages the sensors in a creative way, okay? So I have a few examples of that.
Excuse me.
Yeah.
Did you say that MAC address nowadays changes?
Yep.
No.
Yeah, it does.
Are you serious?
Yeah.
How it can do so?
Because the broadcasted sense of the signal when the Bluetooth scanning. If I monitor now, the values I get, the second round, it will be different. I can show you.
Okay, MAC address used to be.
I know, but the broadcast that Bluetooth is sending nowadays on Apple and Google devices changes. Unless it's a paired device. So for example, this guy here never changes. So it's the same. But for example, my phone with your
It is
phone,
only in Bluetooth.
yes,
Right.
yes.
Not in.
Not like Wi-Fi, yes. Luckily for the advertising. That's why you have free Wi-Fi on the stores. Because they know it's you. The MAC address is the same. Okay? But anyway, I won't go into that. But good question. So here's an example of how we use sensors on a mobile device to do something beyond what we could think of. So what you're looking here is actually Parkinson's disease. And this is the signal coming from a patient with medication and without medication. This is actually using accelerometer data from a wearable, Android Wear, okay? And what you see here is the difference in the signal that happens between when they don't have medication versus when they have medication, just doing this motion. That's it. This allowed us to start thinking about, okay, can we use these sensors to monitor whether or not someone needs to take medication? So the big challenge of Parkinson's is, for example, the reliance on dopamine. I don't know how familiar you are with dopamine. Dopamine is probably one of the most addictive substances in the world, as high as heroin. And what this means is that patients with Parkinson's actually develop an addiction to the medication they take. And they over-medicate a lot of times, which end up making them shake even more than the actual disease, which is quite tricky. And so we actually did an application that allowed them to pretty much assess whether or not they should take the medication or not, regardless of how much symptoms they felt, or they thought they would feel. This is actually the work here by Elena and Valerie. So she's right here. Whoops. Valerie's here. Yes. So this is one example of how we used both the person as a sensor, as well as the phone itself as a sensor. So basically we asked them to play a game where they have the phone like this, and they have to keep the ball in the middle. And by monitoring how difficult that task was for them, we could assess whether or not the medication is starting to wear off, and remind them to take the medication. So the other thing was that for Parkinson's, a lot of the times people are older and they forget that they took the medication, and then they take the medication twice, or they don't take the medication at all, which makes it tricky for the doctor to provide them with useful insight, whether or not is the medication effective, should we switch to a different medication, and things like that. Okay. Another example was done here by Kennedy and Simon, who is my PhD student. Oops, back. And this is an application to monitor elderly care. Wake up. Yeah, so we made this app for nurses to help them do their job, basically. And we didn't want to replace them or anything like that, but we wanted to give them some data regarding how the patients were physically active, how well were they sleeping, what kind of resources were missing in the elderly care center, and then also this self-reported data. And I don't know if you remember or if you noticed here, we don't have to be 100% accurate. We were 86% accurate in knowing where someone was in the room. But that was accurate enough for the nurses to know where to go if they needed something. So if elder is somewhere in the whole building and something is happening, if a nurse says, oh, I need help, they need to know where that nurse is immediately. The space here was quite small, so most of this, knowing where the nurse is, they can just follow the noise, here, stuff like that, and just go there. But, you know, for the nurses, it also gave them an overview of the things that they could improve. So one thing that they noticed was that they spent on average 30 minutes with the person. If you think about it, that's very little if you think about elderly care, right? And that is really strange. And the reason for that is that they go there in the morning, they check on them, they leave. They need to check everyone else. So they are there like maybe 2-3 minutes to check, okay, I'm awake, everything's fine. Maybe help them dress up, and that's it. And then they go to have breakfast, and then they might see them again for lunchtime to check on them, check if they need to go to the bathroom, things like this. Things that take 1-2 minutes. So overall, the whole day, it's 30 minutes, 40 minutes that they would spend per person for that specific person. And basically that allowed them to start reflecting on the kind of activities they do with these elders. So the place where we deployed this, actually, they started organizing social events, things like game night and things like this, where the elders could play cards and domino, whatever. Yeah. But you know, if they don't have this data, they cannot do anything. So now the next step for this is actually to show this data to the family members, so they can see like when was the last time they came visit, how has the person been, has it been sick, and things like this. During my PhD, I also built this application that I thought would make job easier for doctors to collect this self-reported data. We have a video here of that, so I will just put that playing so you can see.
This is John. John is a healthcare professional. John wants to give the best service to his busy patients. This is Kate. Kate is a talented business executive. Kate is excited at the prospect of using personal technology devices to monitor her health and to improve her well-being. But John and Kate can't work together. John loses time trying to understand new technologies, and Kate loses money buying expensive gadgets that wear out. But their problem is solved when they use Aware.
Woohoo!
Aware is an app that enables its user to turn their smartphone into high-end health tracking instruments. The Aware framework is being developed by world-leading experts. It has privacy by design, and it's free for life. So this is how Aware works. First, download Aware on your smartphone from your trusted app store. Next, the app is configured to use your phone sensors and track your activities. Finally, you can decide to share your data with your doctor in real time. As a doctor, you can use Aware to monitor multiple users. Now, John and Kate can take full advantage of advanced technology and transform their practices to meet the evolving needs of the people they love and serve. Aware, intelligence in your pocket.
So this is the kind of videos I hope to see when you guys finish your project. So, so we've been using Aware to look into all of these examples I gave. So Parkinson's, the elderly care. We're now using it for monitoring depression. We have actually a visitor coming from Tampere today that wants to use Aware to monitor, for example, student motivation and worries about future and job prospects and all of this stuff. Yeah, so if you think about your project, you should think about your project as something that you would see of not wasting your time and something that you can be proud of at the end. Okay, don't do it just because of doing the class, but do it because of yourself. What is your driver? Okay, is it a game? Is it? I don't care really, but it just needs to be something that comes from your own interest. Because I think the best projects come from that. And of course, we will do our best to support that. We had companies start off this class. So I would just encourage you, if you really want to do that, let's do it. And that's fine. We can talk about it, what kind of needs you will have and sensors you might use. How would you do a prototype of what could potentially be a future job for you? Okay. So that's it. That's all I have for today. We actually ended ahead of time. Do you have any questions regarding the class today or the previous classes regarding the project? Have you guys started thinking about your project? What do you want to do? We can talk a bit about that. Is it too early in the morning? So what kind of ideas have you guys thought about for your own projects? Anyone? You're in front.
Gatehouse designing is could notify other people to take their medicine.
Okay.
Basically, there are these boxes that other people use for their medicines.
Yeah.
For Monday, Tuesday,
Yes.
and we are going to implement a button in there, which will be connected to the phone by Bluetooth.
Okay.
And every time a medicine time comes, the phone will notify the people by sending a notification.
Yeah.
And if the person takes the medication, it will press the button to shut the alarm down.
So you're gonna bug them until they take the medication?
Yes.
Cool. Okay.
Because they forget.
Yeah. Okay. What device are you using? Raspberry Pi or an Arduino? How are you connecting?
Arduino.
Arduino. Okay. Cool. Anyone else?
Okay.
Yes.
Same.
Same.
Team.
Jeez. Okay. What about you, Leslie? What do you think? Big project.
Actually, I was sending emails for you during the weekend asking for remote you didn't communicate later, but you didn't recheck that. So I do maybe my
Okay.
but I follow this.
Okay.
Yes.
You? What do you think? No project?
We have now finalized it and figure out.
Okay, so you don't have yet an idea. Okay.
We are planning it of this.
Sorry?
We are doing our first planning meeting after this.
Okay. Well, I hope you guys got some motivation and some inspiration, let's say.
Well, we don't have anything yet, but I bet that we are going to meet maybe today.
Okay.
As well.
Yeah, just make sure that, you start thinking about this. It takes some time for an idea to emerge, and I'm pretty sure the first meeting is going to be a bit like, oh, okay, what are we going to do? A lot of the times, actually, what has happened is that students come up with an idea for the first 7 weeks, and then they go to spring break, and I don't know what happens in there. They always have the best ideas after that. So I don't know if that just has to do with, have some free time to think and, but the sooner you start thinking about this, the better it is for you. And it is okay to change idea, okay? So that's the other thing that I wanted to let you know, that even if you started having some ideas here and for these assignments, the reason we're asking these is so that it really forces you to start thinking about, how is this going to work, and things change. That's why it's a plan. Plans change, okay? So don't be afraid that, okay, we have this idea, you're not stuck with it, okay? So it's okay to readjust and rethink things because, you will learn more as we go, and on the labs you'll also learn more things, so it's natural, okay? What about you guys? What are you thinking?
I'm now thinking about what should be made.
Okay. You? Okay. All right. Okay, well, I guess, any more questions? No? Okay, I guess you guys can go have coffee and enjoy the rest. Okay, all right, I'll see you guys. Hey, just a second. Yep, let me just turn this off.